Okay, very quick information for you. Okay, so I still have my office hour today between 4 and 6 p.m. If you have some last minute question regarding the test, please feel free to come by. And I just sent out, right before I came to the class, I sent you the first 2 pages of the instruction for tomorrow, just about how you can import the projects and how you can make your submission. So feel free to read it through before tomorrow. It will be identical. Okay, so it can save you some time. Okay, the first 2 pages of your lab test instruction is already there. Okay, read it through. But tomorrow you're going to submit by the terminal, not web submit. Okay, it's going to be a little bit different. Okay, just make sure you read it through. Okay, so now I would like to start with this example here. I made some slight confusion to you, possibly. What happened was the diagram I drew on the iPad was not exactly the same as what's said in the slides. What I said last time was completely valid, but somehow it's just different from what's in the slides. Let me just do it once more very quickly. So you should know how to define or override the equals method for your lab test tomorrow. Okay, let's just review very quickly. Okay, let's see what we have over here. Okay, let's see. Okay, any question you have, you can stop me. Otherwise, I'm going to go just tell you what you should know about this particular example. Basically, let's have a look at the test we are having over here. Basically, we just have some PC1, which is a point collector. We are trying to add P1 into it, and also adding P2 into another point collector, PC2. Okay, and then we are somehow trying to call the equals method on each one of them. Okay, that's basically what we are trying to do here. And let's remind ourselves how we can define the equals method over here. Okay, this is the equals method for point collector. Okay, everything up to the cast will just be the same as just standard. What you should really realize is this part of the code. Okay, about how you can write a for loop and try to go over each point one by one, and then possibly call the equals method that we defined previously for the person class. Okay, so now you can see that over here we got a person class where we also got an equals method over rhythm, right? We can simply reuse it. So now let me just go straight to the points. I want to just do a few assertions with you. So this might be what you're given tomorrow. So what you should really figure out is how exactly should you define equality between, let's say, person collectors. Okay, let's try very quickly. Let's see the first one. So basically, let's see the first one, assert false over here. Okay, so we simply got PC1, which is here. That's PC1. We are trying to add P1 into it. If you follow the pattern faithfully, so what you will do is at position 0, it is going to point to this particular P1. And NOP should be incremented to 1. Okay, assuming that you have implemented it correctly. So now, if we try to do this assertion right away, to say PC1 dot equals PC2. The context object is PC1, so that means we're going to call the overridden version of the equals method, which is exactly over here. Okay, so now conceptually, you're basically talking about PC1 over here versus PC2. If you simply look at their NOP, one of them is 1. The other one is simply just 0. They are unequal right away. So make sure your implementation can cover this properly. Okay? So that is why you will see assert false, because PC1 that equals PC2 will just give you false, because they store different number of points. Okay? That one's easy. Let's try another assertion. Okay? So now let's say we go on to change PC2. And then you can see now the context object for add person over here is PC2. That means we are trying to change PC2 over here, and we are saying add person P2. So where is P2? P2 is a different person object, but notice the following. You can see between P1 and P2, are they considered as equal persons? They will be, because you can see A, lower A, 180, 180, 1.8, and 1.8. So they are pairwise equal for the attribute values. So according to our persons equals method, these two persons are equal, right? So now let's see this. After you have added P2 into PC2, what's going to happen is now PC2 at point at index 0, rather than pointing to null, is now going to point to this particular point, right? And also NOP will be incremented to 1. So now you can see we are having a slightly different case. You can see the NOP for the 2 point collector are simply just 1. But now are they considered as equal point collectors? That's the question, right? Let's now have a quick look for that one. You can see over here, if we say, first of all, PC1.person0, what's PC1.person0? PC1 is over here, and then we want to go to first index. So we are talking about this particular object over here, right? And then we're trying to say PC2.persons at position 0. So in this case, if you go for PC2, and then persons is pointing to this array, and then position 0 is now pointing to this particular array. Basically, we're talking about this array, this person and this person. If we simply compare their references, they are false because they are not the same references. On the other hand, if you try the following, to say PC1.person0, which is this person over here, dot equals PC2.person0, which is this person over here. So now, which version of the equals are we calling? In person? Overridden, I agree. Yes, I agree. But now, is it from the person collector? Is it from the person? Is it from string? Or is it from objects? Person, okay, very good. So now if you look at that, because we know that this particular context object here is of type person. Okay, and we know that we're going to call this particular version over here for the person. So you're going to compare them, and they're just the same. So that is why you will see assert true over here, because it will simply give you true. Okay, I think that will be it. Okay, for the rest, you can simply just try to add more persons into person collector and see how they will do. Okay, I would say for the lab test, you can expect something similar. There shouldn't be too much surprise to you. Okay, any question about overriding the equals method for collector? Any questions? Okay, okay. If you're okay with that, why don't we go back to our compareTo method, comparable. Okay. So now let me go back to the slides over here. So this is the example that we introduced to you last time. Let me just go over very quickly. So why do we bother with defining and ordering between objects? Okay, let's see one example. Let's say we got employees over here, and let's just go over this on the iPad quickly. So that's a table that we looked at last week. So we got Alan, we got Mark, and also we got Tom. Okay. You got either ID or you got salary. You got different characteristics for each employee. So now, notice that you can see the ID, if you only want to sort by ID, Tom's ID is the smallest, okay? Whereas Mark's ID is the largest, okay? If you somehow want to sort according to salary, you can see Mark's salary over here somehow is equal to Tom's salary. They're equal. However, in the second way of sorting, we want to say based on salaries and IDs. So the lesson is, in reality, you may have so many characteristics for between two objects. You can choose only certain characteristics to do the comparison. Okay? Now here, in this case number 1, we want to sort only based on the ID. That's one case. In that case, we'll see that, in this case, we'll simply get Tom first, and then Alan, and then Mark. Okay, because you got 1, and then 2, and then 3. That's according to the IDs. Okay. Now let's change the sorting criteria for, a little bit. So let's say not just on IDs, but also salary first. Whoever gets a higher salary should come first. In that case, we know that Alan, who got the largest salary over here, should come first. So that's why we put Alan first. And then you can see for Mark and Tom, they have equal salary. In this case, we cannot really tell. So go further to compare the ID. In this case, Tom got smaller ID. He should come first. Okay? And then we got Tom, and then we got Mark. Okay? Notice one thing. Let me summarize so we are on the same page. Over here, you can see that this is one way to order. This is order number 1, pink. This is order number 2, yellow. You may have different orders depending upon how you want to compare them, the ordering. But how can we implement this in Java? The answer is you will have to use 2 things. Okay, let me just go to the slides and then we'll do coding together. The solution to actually have different kinds of ordering is, number 1, you want to define ordering in the employee objects. How do you do that? You have to implements the so-called compareTo method, which is very easy, just some conceptual ambiguities I want to clarify before we can do it. And then also after that, you can use some library class called Arrays. You can simply sort. You don't actually have to implement a sorting procedure yourself. It's already done for you. But in order to use the sort mechanism over here, you will have to define the ordering yourself in the compareTo. Okay, these are the two things we're going to see. Okay, let me point out to you one more thing before we start coding. Okay, let's go back here. I want you to notice one thing. Whenever we talk about the final sequence that we want to have for the sorting, this is sequence number 1. And this is sequence number 2, right? We got two possible sequences. Nothing about right or wrong. It just depends on what we want. For sequence number 1, we are considering Tom to be less than Alan. Alan is considered to be less than Mark, simply because the way we define the less than over here is simply just by their ID. So in this case, they simply just correspond to the less than over here. That's a simple case. Okay? The second case is a little bit more complicated in the following sense. If you look at that over here, if you look at, let me just write it out. For sequence number 2, Alan is considered as smaller than Tom because it comes before Tom. And also Tom is considered as smaller than Mark. However, notice that if we compare this particular ordering just with the ID comparison alone, you can see Alan, Tom, and Mark is different from Tom, Alan, and Mark. Right? It's not exactly the same. So that's completely normal. So that means somehow you want to combine this ordering over here and this ordering over here in a way so that you can have the resulting ordering over here. Okay? That's kind of the idea. So now in our compareTo method that we're going to write, we'll see exactly how we can define for sequence 1, and then we can see how we can define for sequence 2. We're going to see that. Okay? Any question conceptually? Okay? Let's see how we can do it. All right? Let me just go back to over here. Okay, let's see how we can do it. Let's see a very first example. Let's say we have an employee class over here, employee, and then we got ID, we got salary, right? The thing is only two characteristics to worry about. You can simply initialize an employee with their ID, and also you can set their salary to be a certain number, double. Okay? Now, let's see what we can do. You can see so far, this is the only thing we have in the class. There is no compareTo method that's defined, right? Let's try to do something just to illustrate to you. Let's say I'm trying to write a JUnit test, okay? I'm simply trying to create Alan, Mark, and Tom with the corresponding ID. By the way, everything I create over here simply corresponds to the table over here, right? IDs 2, 3, and 1, and salary over here, the same, okay? So now let's have a look. I simply created 3 employees with different IDs, and also I try to set, try to get an array. So for line number 6, hopefully you're comfortable with this notation here for array. We have seen that many times. Okay? I simply put Alan, Mark, and Tom. They are not sorted just yet. And then if I say Arrays.sort, I'm calling the library method class called Arrays. And sort is simply just a static method, which means I can call that without creating an object. Okay? And then sort ES. So now I'm simply saying now I expected the outcome to be Tom, Alan, and Mark, for example. Let's say I expected that. And then there is something also very useful for you. Okay, assert array equals. You can simply put 2 arrays and compare them. I'm saying that the expected outcome, Tom, Alan, and Mark, should be the same as after ES over here has been sorted. Okay? Now, everything compiled up to this point. If I try to run this test, what's going to happen? Do you think it might be a pass, it might be a fail, or it might be something else? Okay, I'll give you a little bit of hints. Over here, I'm saying when you try to sort the ES array, employees array, I expect it to be Tom, Alan, and Mark. Let's recall. Tom, Alan, and Mark is simply sequence number 1 that we had previously. That's a sequence number 1. Tom, Alan, and Mark. with the assumption that we are comparing the IDs. Okay? If you look back to the class over here, did we say anywhere in the employee class that every time you're trying to compare two employees, we're going to compare based on their IDs? No. So even though the code compiles, what you will get is class cast exception. Okay? That's something number one to note to you. Every time if you want to use line number 7, use Arrays.sort method, it will be very useful. However, you want to make sure the class you're trying to compare the objects on, they should be defining the compareTo method. That's the point. Okay? So in this case, you will just get class cast exception. How do we fix it? Well, given that we got two possible ordering sequences, either sequence 1 or sequence 2, depending on the different criteria for comparison, we have to now see two different versions of compareTo and see how we can do that. Okay, that's the point. That's why I'm showing you this error case first before we see the correct one. For the correct version, we got two versions. Okay, either based on IDs or salaries and IDs. Okay, so the Arrays.sort, you can feel free to click on the link to see the API for Arrays.sort. It tells you it's required the employee class, in this case, must have the compareTo method overridden. So now let's see how we can implement that. Okay, let's go over some concept. Okay, let's say you have an array of. Okay, you can see over here we have an array, right? It's simply called CES. CE standing for comparable employee 1, version number 1. Okay, so now conceptually you have to think in this way. I want to rearrange the array of the comparable employees in such a way that it is considered at index 0, the employee is actually smaller than or equal to the employee in the second position, and also all the way to the last one. Basically, I'm going to sort them conceptually. But now here's a problem. How do you define to say 1 is less than or equal to? What do you really mean by that? So that's really up to you as a programmer. You should really figure it out. Okay, let's see. So now, in order for you to compare two employees, here's the idea. As soon as you try to implement the compareTo methods, so here's the idea. If you have, let's say, CE1, comparable employee 1, compared to CE2, always it returns an integer, always. And now, the value of the integer itself is not so important. It is the sign of the integer that's important. Either positive, equal to 0, or negative. Only these three possibilities. Okay? When you have, let's say, CE1, then compared to CE2 larger than 0, conceptually that means CE1 is larger than CE2, conceptually. Okay? We're going to see an example in just a moment. And then if it is simply equal to 0, that means they're considered as equal. So now, when you are trying to design your compareTo, you want to make sure whenever you return 0 from compareTo, you should somehow be consistent with the equals method of your class, right? And also, if that's negative, that simply means CE1 is conceptually smaller than. Okay? I think these are the two most important conceptual points you want to get clear. Okay, after this, let's consider our first version for the compareTo. So how do you make your class comparable? First of all, you're going to declare your class CEmployee1, comparable employee 1. And then you would say increments. We'll explain exactly what increments versus extends really mean. Increment simply means I'm trying to implement certain interface in Java. We'll talk about interface once we get to inheritance. For now, you can assume that it's always given to you for now. Okay? I'm simply saying I'm going to implement the comparable interface where each element in the collection in the array is simply CEmployee1, version 1. And now, let's have a quick look of how the compareTo method will look like. All the attributes, accessor, mutator for employee will just be the same, so I don't bother you with that. Let's have a look at this method here. Okay, I'll switch the context right away. This is version 1. Version 1 over here, basically what we are doing is we are going to say sorting based on just the IDs. Sorry, there's a typo. Based on IDs only, just the IDs. And then you can see that there's only a one-line implementation for compareTo. Okay, let me just switch here. Sorry. That's what I meant to go. Let's say this. We got comparable employee 1 implements a comparable. And now there's only a one-line implementation for compareTo. Look at what we said. Return this.id minus the other one.id. Okay, you can see this is other. Before we even go to the test case, think about what this is doing. Just for example, let's say if the current.id is simply 3, and then e.id, let's say it is 1. In this case, the result is actually going to be plus. Conceptually, what does that really mean? Greater than, right? So that simply means this is somehow considered as greater than e. Okay, somehow. On the other hand, if I got 1 and 3 over here, smaller than. So that means negative. Conceptually, this is smaller than e. So in this case, this should appear earlier in the sorted sequence compared with the other. Okay, as long as, again, this clarified, nothing's hard. Okay, let's have a quick look. And I'll do a little bit illustration for you. Okay, so now let's have a look. So now let's say we simply try to create the objects over here. So now Alan is going to be 2, Mark is 3, and then 1 for Tom. And then that's a 445,000 and 3450, 3450. Okay, just omit the fractional part. So now we still create this particular array over here, and then we simply call Arrays.sort. But now this time we are not going to get any class cast exception, simply because we already overridden we already implemented the compareTo method. So now we want to know. I can tell you the expected result will just be Tom followed by Alan followed by Mark. Okay, but now why is that? Okay, let me help you a little bit. Okay, for the simple example, you can think using a table over here. Okay, you can see that according to our definition over here, we only compare using ID. That's why we simply say this.id minus e.id. Okay, so now I want you to I'll just tell you how you can fill in this table here. Okay, what's going to happen if I say Alan.compareTo Alan? What would that be? 0. You will simply say Alan.id minus Alan.id. So that would just be 0. So that means we're considering Alan is the same as, okay, let's say equal sign here. It doesn't mean assignment, it means equality, okay? The same as Alan. Let's do one more. What about if I say Alan.compareTo Mark? What would that be? Alan.compareTo Mark would be 2 minus 3 would be minus 1. So that means it's considered as smaller. So that means when you look at this final sequence over here, you can see Alan appears before Mark. Okay? So of course, you can simply try to fill in the entire table. You can actually see why we got a final outcome. However, you can imagine that there's an underlying procedure in Arrays.sort. They are simply just going to compare pairwise the objects according to the compareTo you just had, and then figure out exactly what should be the final order. Okay? For your information, Arrays.sort, if you look at the API, they use something called merge sort. This is something that we hope to cover maybe towards the end of the course. It's a very efficient sorting algorithm using recursion, but we'll get there if we get a chance. Okay? I wouldn't bother you with the entire table, but you get the idea. Basically, you can imagine a sorting procedure is going to fill in the table with less than, greater than, or equal to 0, right? And then figure out the order. Any questions for the simple case? Okay, so now let's see the slightly more complicated case. So what I would like to do is to consider case number 2. Case number 2, we're going to sort based on salaries. If the salary is higher, appear first. If the salaries are the same, whoever the ID is smaller, they should come first. Okay? Notice that we talk about higher salaries comes first, rather than lower salary come first. And then we say smaller IDs come first, rather than larger ID come first, right? Let's now have a look. Okay, let's see how we can do that. One way to go Okay, I'll show you the implementation directly. One way to go is by saying, you can simply say if this the salary is larger than other the salary, and then I simply return -1. Can anybody try to explain to me the logic over here? Why am I returning -1 as opposed to +1? That's a very important question to answer. Let me write down my question here, okay? Why not -1? I'll give you a little bit hints just before I point to you, okay? Hints would be, number one, think about what kind of employees should come first in the final sorted sequence. That's number one. And number two, if I return -1, what does that mean? Okay? I'll point to you maybe for the next one, okay? You want to try? Yes?
Because you want the higher salary first, right?
Yeah.
So returning -1, it's going to return that one first instead of...
Yes, exactly. So over here, if you see that, that's exactly right. So now let's look at this. So now, if you look at the condition over here, you will see that here, this the salary is larger than other the salary. We know that this should come first. And the way to make it come first is by returning something that's negative. That is why. Okay, good. Similar logic here. Otherwise, if salary is less than that, that means you come later. In that case, you return a positive. Okay? And otherwise, if they are equal, in that case, we'll simply just try to sort based on their IDs. In this case, smaller ID should come first. So that means if the ID is simply 2, other the ID is simply 3, that'll be -1. That'll be okay. You just come first. Okay? That's the logic for this second implementation. Okay? Guys, any question for this? Please.
So does it matter what, so if ID is quote unquote stronger than salary,
Okay.
a stronger condition than salary and vice versa?
Sure. So you're asking the following question. At the moment, this version over here, salary is considered the first criterion to consider. Yeah, stronger criterion. Yes, I agree. Okay, let me write it down. In that case, basically, for this particular code, you can think about salary is a stronger criterion to consider first. Okay, you're basically asking the following question. What if we change our conceptual comparison criterion a little bit differently? Let's say this. Let's say this is not a new criterion. Let's say smaller IDs come first. If equal IDs, then higher salary come first. Okay, question number one. Should this make a difference compared with the other one? I'll give you one example just to get you understood. Okay? Let's say this. I'll simply just put A and B. Okay? Employee A, employee B. Let's say this. ID and also salary. Let's say we simply got, let's say, salary over here, let's say 45,000. And this guy here is going to be, let's say, 30,000. Okay? According to the previous criterion, because the salary is already higher for A, right? In that case, it's going to be A followed by B no matter what. Okay? That's the original criterion. Original criterion. Okay? However, what if I try the following? For ID, I'm simply going to put, let's say, 1 and then 2. Now, according to the blue second criterion I have, who should come first? B and then A. Because we simply compare the ID first. Doesn't matter if the salary is higher or lower, right? In that case, that'll be B and A. This is in the revised criterion. Okay, conceptually that's how you can understand it. But now, how can we rewrite the if statement a little bit differently? Okay, it's going to be very simple. Okay, I'll show it to you. Okay, basically let's refer back to our code over here. Okay, so what I will do is I'm going to show you the comparison. Okay, we're going to go for this particular way. This is the original criterion where we compare salary first and then the ID. So now we want to do ID first and then salary. Code structure will be very similar, but now rather than comparing salary first, we're going to compare ID first. So now, should it remain to be -1 or should it be +1? Well, if the ID is larger, that means you should count later, right? Yes, very good. That should be +1. Okay? And then if the ID is smaller, over here, that should be -1, okay, symmetrically, right? So now what happened to the else? What should we do? Apparently, we don't do ID anymore. If I simply say this, if I simply say this dot salary minus other dot salary, do you think that might work? Would that work?
This problem in particular, there's no way, because IDs are supposed to be all different, there's no way we can get to the else.
Oh, yeah, that's fine. I'm just talking about in the general case. Yeah, in general. Do you think that this dot salary minus other salary should be returned directly, or should we invert the sign? Let's, if you're struggling with the code directly, why don't we think about some example, right? Let's say, for example, if this dot salary is 45,000, other dot salary is 30,000, what this will give to us is a plus sign. Agree? Plus sign simply means this employee with a higher salary is going to come later in the sorted sequence. Is that what we wanted? No, higher salary should come first, come earlier. So that's why you should really negate it. Okay, that's kind of the derivation process. Always think about what does it really mean for an employee or the object to come earlier in the sorted sequence than the other, and then think about the sign. Okay, that's my point. But I think it's a good question. So you should really think about, if I swap the criterion a little bit, maybe you should redefine the code. Okay, that's the point. Any question about what we have got so far? Okay. If you're comfortable with it, why don't we go for one more version, okay? There's another version there. Let's go back to the original criterion where we say higher salary and then higher, smaller ID. Questions? Go ahead. Salary is double, yes. Nope, nope. What I meant, oh, I see what you mean, yes. So yeah, I'll just say conceptually. Of course, once you say whatever salary the minus is, you may just say if the salary is larger than 0, you may just say return -1, something like that. Yeah, okay. If you really like it, I can say if this dot salary minus other dot salary less than 0, let's say, in that case, they should count later. In this case, it would say return +1, for example, right? Something like that. That's not a problem. But we will see something very handy for you in just a moment. Okay. Okay, let's go back to another version. How about this version over here? Okay, so now this version is a little bit trickier, well, a little bit more concise. But let's see if you can understand what's going on over here. Let's go over that together. Basically, what we're doing over here is we're still trying to redefine the compareTo method here, okay? And then we'll just call that employee number 2, version number 2. And then we say, first of all, let's calculate the difference between the salaries. And we simply call this a class called double in Java. And there is a static method called compare. You simply give 2 double numbers. What that would do is, if the difference between, if you say this salary minus other salary happens to be negative, you'll give you -1. If this dot salary minus other dot salary is positive, you'll give you +1 or 0 otherwise. Okay? It'll simply give you the difference. And then we say that we drew another one, call that the difference between the ID. And then this dot ID minus other dot ID. Okay? Basically, we got 2 differences. difference between the salary and difference between the ID. And now, do you think you might be convinced the if then else over here? If you read the if part, we're saying if salary difference is not equal to 0, that means their salaries are not the same. One has to be higher than the other. Now in this case, why are we inverting the sign? Similar logic here. Why are we inverting the sign? Yep, exactly. Higher salary should go before. Okay. Again, example. This the salary if that's 45,000. Other the salary is simply 30,000. What double the compare will do, because 45,000 minus 30,000 is positive, right? It will simply just give you +1. However, this with a higher salary should come before other in the sorted sequence. That's why we should invert the sign to be negative. Okay, that's a very key insight. Okay, let's say if you go to the else part, that means not equal to is false. That means the salary are the same. You simply return the difference between ID, right? In this case, smaller ID should come first. Okay. Guys, any question until now? We okay? All right. compareTo is not that difficult. I would say it's mainly the two levels you want to think about. Think about the final sorted sequence and think about how you define a compareTo. That's the main part. Okay. Okay, let's see what else. I may have just a simple exercise for you to think about before we finish the topic. It's very easy. Okay, so now if you try to run the same test, it's simply just going to pass. Okay, everything has been gone over. Okay. I want to mention just something very quickly for you. Whenever you're trying to define your compareTo method, you want to follow some principle, right? That's a little bit more formal. Let me explain to you what does it really mean. Okay, if you look at that, C1.compareTo C2. Okay, C1.compareTo C2. If that's less than 0, conceptually C1 is less than C2. Agree? If C2.compareTo C1 is less than 0, that means conceptually C2 is less than C1. This simply means negation. That means it should never be the case that this is true and also this is true. For example, in the case of numbers, 4 less than 2 and 2 less than 4 should not be true at the same time, right? Should be exactly one of them that's being true. Okay? That's what this means. Okay? You want to make sure. The second one is even easier. If I tell you I is smaller than j and j is smaller than k, wouldn't you agree? I should be less than k, right? That's exactly what's being said here. This guy here, if the compareTo less than 0, C1 less than C2. And over here, compareTo is less than 0. That means C2 is less than C3. That simply means C1 is less than C3. Okay, it's so-called transitivity. So these are the two properties you want to watch out for. Okay. For example, if I give you a compareTo method, I ask you whether this compareTo is appropriate or not. These are the two criteria you have to apply to judge. Okay. One exercise for you, for everybody. Okay, quickly. Let's go back here, and then let's have a look at this. How would you define the compareTo method for the player class of a rock, paper, scissors game? You know how to play rock, paper, scissors, right? I assume. So now let's say we have a player class, and then we want to say one player is considered as smaller if they actually win the game, right? And each player can either play rock or paper or scissors. So now the question is it possible, if so, suggest a possibility, is it possible to define a compareTo method for rock, paper, scissors player? Hint for you. Have a look at the asymmetric and transitive. That's a hint for you. Anybody? Before I give a little bit further hints. How about the second one, transitive? Well, let's say this. Let's say I got player A, player B, and player C, right? let's say player A simply play rock. And then player B plays scissors. Rock wins over scissors. So that means conceptually A less than B because it's going to appear earlier. And now let's say scissor and then this one has paper, let's say. So that means scissor is going to win over paper, agree? So that means B is less than C. According to transitivity, it tells us A should be less than C. Now, does rock win over paper? No. We got contradiction. You see my derivation process over here? Okay? Let me say it again quickly. Think about A, B, and C. A has a strategy that's going to win over B. So that's why I say A less than B. Okay? A less than. B also got a strategy win over C. That's why B is less than C. By transitivity, we say that A should be winning over C. In this case, rock should win over paper. In that case, no. Contradiction. So it is not possible to have a compareTo method for the rock, paper, scissors player game because transitivity is simply not possible. In some way, the game for the rock, paper, scissors is circular. Right? You cannot have a strict ordering between any two players. Guys, do you follow over here? Okay? Yeah. compareTo is actually not that difficult. I think maybe just study a little bit and try to practice a little bit for the programming. Right? I think you should be fine. Okay, if no questions, let's enter another interesting topic. Map, and also hash table. Okay, let's see how much we can do. Okay, what is a map? Any one of you actually used hash map or hash table previously in your lab? Or, okay, guess very few of you, only you, I guess. That's fine, doesn't matter. Okay, let's learn it. Let's say what a map is. A map, sometimes we call a table or dictionary. It's simply going to be a collection of entries. So let's define what entry is. Each entry actually, oh, let's see some example over here. I'm not sure if you're old enough to actually have seen such a thing. You know, in the old days, how people keep track of stuff. I did it back in my university, actually, so I'm, yeah, anyway. So over here, you know, they actually got a cabinet over there. It's called a map. Each entry is simply like a portfolio paper copy folder. And they actually got a label, like a sticker over there to tell you what report it is. Maybe it's a report for Q2 or it's a report for Q1. That's so-called a key. By saying I want to find out the Q2 report, I will look through the map, the cabinets, and look for that particular label. It's guaranteed to be unique. Once I find out the label, put out the portfolio, I can see what's inside, the value. Okay? Anyway, that's one way to think of it. Okay? Or think about your mobile phone. Whenever, if you, in your contacts, if you simply type in the last name of your friend, you can uniquely identify somebody in your address book, typically, right? It's also a map, okay? So this is the concept between key and value. So now let's think about a little bit more abstractly what map is. You can think about a map is simply like a table with two columns. Column number one, usually I put on the left, is the key or search key. It's for search purpose. And the second column is the value. And notice one thing over here. For the left column there, all the keys should be no duplicates. Okay, so whenever you want to find out a particular entry, you should pass a key that uniquely identify the row. Okay, we'll see example. And for the value over here, I simply just put character. Okay, in general, the search key does not have to be integer. It can be even objects in Java. Okay, but just for illustration purpose, we say it's integer. Okay, we got search key, also we got entry. Okay. Each entry is simply a pair with a value and search key, okay? And also, each search key is simply, number one, is going to uniquely identify an object in the map, okay? If I give you, for example, the key 25, you should tell me the corresponding value should be C. If I tell you the key for 40, for example, 40 doesn't exist. It should give you back null, for example, okay? Now, the second part is important for this particular topic. We wanted to make the retrieval of an entry from the map as efficient as possible. We haven't really talked about time complexity just yet. We will later in the course. But now, this lecture, I just want to give you a little bit intuition, okay? But we'll get there. So we want to be as efficient as possible. We'll see what efficient really means in just a moment. Okay, and the search key must be unique. Okay. For example, let's imagine. Can you imagine if you simply replace the 25 over here by just 1? Okay, that means 1 maps to D and also 1 maps to C. In that case, if I say, give me the value associated with 1, you wouldn't know which one to return, right? You got ambiguity over there. So now, let's now, given a very brief briefing of what a map is, can you imagine array is actually a map? Array. Good. What are the keys? Indices. Okay, very good. What about the values? Whatever you store in the array. Array is the basic, the most basic case for the map. Okay, you guys are pretty good. Why don't we go over that very quickly? Let's say each entry of, so array is simply a map. Okay, each entry is just a pair with the objects being stored being the value and also numerical index being the key. Okay, no duplicates of the indices for sure. And now let's say this. Over here, tell me something. If you got an array of string and simply A, B, and C, how many keys do you have? What are the 3 keys? 0, 1, and 2. And values A, B, and C. Okay? Now, if I say I give you key 1, what would be the corresponding value? B. Okay, careful, yeah. So now if I give you index, if I give you key -1, what would be the corresponding value? Should be conceptually now. Of course, you will get array index out of bound exception, right? Good. Okay, that's very easy. Okay, I wouldn't bother you too much. So now over here, 3 entries, 0A, 1B, and 2C, okay? Usually we put key first and then the value. Okay, we've got search keys. They are simply indices, and it will be unique because it goes from 0 until a.length -1. Okay, make sure you know what a.length really means. You will need that for tomorrow. Okay, please. Okay, and given a valid index value, we can definitely go to that particular position, right? If I give you index I, because indices start with 0, that should be I plus 1th item, right? And also, it will be very efficient. This is something you will learn more details about how the array indexing can be calculated. Basically, it will be like a direct address lookup into your memory. Okay, you don't have to worry about this detail for this course. You can just take it for granted. Always array indexing is very efficient, very fast. Okay. Okay, now one more thing before we see more examples. Maps in general, the keys does not have to be integer. To be honest with you, in many cases, they're simply not integers. They can just be objects. For example, let's see. Let's say you have, let's say student ID. Student ID can simply be just keys for your student record database. Student ID can either be integer or maybe a string, because you might have A, 1, 2, 3, 4, 5, right? Maybe there's some non-numerical elements there. Or it can be social security number, if you want to store all the Ontario's residents record, right? Also, you got a passport number to store all the Canadian citizens record, and etc. Okay, the point is, once we learn about this particular lecture, you should realize the keys are very general idea. It does not have to be integer. It can be any object type, anything. So now, here's the plan. What we will do is, I'll let you consider this particular problem over here based on what you have learned, assuming that you know nothing about hash table, assuming that, right? Let's say we want to support the construction of this simple map. So we want to insert 7 entries over here. The first one will be 1D, and then 25C, and then 3F, etc. Got 7 entries. And now we want to say the maximum capacity for the map will be up to 100. Okay? So now, how can we implement this? Based on what you have learned from point collector, that's exactly how you can do it, right? Why don't we create an array of size 100 and then keep adding into it? You have some NOE for number of entries counter, right? Before I show you some animation, which will be very easy to understand, before I do that, why don't I show you something very quickly here? Okay, if you look at the code, okay, think about how you're going to do it. Let's say, what about entry? Each entry is going to have 2 attributes. The key, integer, just for simplicity, just integer key. And also the string, value. Okay, 1D, for example, we got 1 and also D. Okay, and also when you construct a new entry, simply take the key and the value. Okay, very easy class. And now let's say we also define another class called array map over here. So let's say we define the maximum capacity to be 100. And then we have entry array and also NOE. Okay, very standard pattern. Okay, we'll simply initialize the array to be the maximum capacity 100. And then every time if you want to know about the size of the map, number of entries, it will simply give you NOE. And then if you want to put in, like add in a new entry, you simply create a new entry accordingly using the key and value in the increment NOE, right? Very easy. So now, before I show you the question or some test case, let's see the animation, okay? I'm gonna show you once. Let's say in the beginning, we have NOE pointing to basically value 0. That means the next available slot will be index 0. If we try to add in the first one, the first entry, and then NOE is gonna be incremented to 1, right? If I add in the second entry, NOE goes to the right. Third one, 4, 5, 6, 7. Make sense? How about do it one more time? That's the first one, second, third, fourth, fifth, sixth, seventh. You can do up to 100 times, okay? So that's about a very quick review of the programming pattern that we have known very well, okay? Now, let's just do one JUnit test to reaffirm our understanding, and I have a critical question for you. Okay, we'll get there. So now I would suggest we go over this particular test case very quickly, okay? And feel free to refer to this, this diagram at the bottom there, okay? So now notice that, so each entry has the key and the value, right? Key and value. 1D, 25C, 3F, 14Z, 6A, 39C, 7 and Q, okay? Just in case you cannot read it, I'll read it out to you. So now let's have a look at the test case very quickly. How do we create a new map? We simply say array map is simply new array map. So in this case, it's going to create an empty array map, just no entries just yet. But the underlying array has null slots, 100 null slots. And then we simply say assert true, m.size would just be 0. That was easy. And then we simply try to say put 1 and D. So 1 over here is the key, and D over here is the value. Okay? Notice that 1, 25, 3, 14, 6, 39, and 7. No duplicates of keys. So maybe what we should have done is to strengthen the code such that we say if there's any duplicate you're trying to add, throw an exception, right? But something I didn't do, just for simplicity. And now, assert true, m.size would just be 7 because I got 1, 2, 3, 4, 5, 6, 7. Okay? So now let's do something here. If I say assert true, m.get, that means I want to inquire about the map by giving you a key value 1. In this case, 1 is simply corresponding to this particular entry where the key value is simply just 1, right? What's the corresponding value? D. Okay, you can see D over here. Sorry, it's a bit small. You can see 1 here, corresponding value is simply just D. Can you see what should be the answer for the second one? You can see m.get now is 7. Is 7 an existing key? Where? Last one here, right? Last entry over here, the key is 7, is match, and then the value should be Q. Okay? Finally, what about 31? Do we have key 31? Right? We only got 1, 25, 3, 14, 6, 39. There is no 31. In that case, the return value should just be null. So the principle is easy. If the key does exist, return the associated value. If the key doesn't exist, return null. Okay? Any question until now? I have a question for you, right? What I haven't shown you was how to implement this particular get method. I haven't shown you yet. Can you imagine how are we supposed to implement this get method? According to this kind of setup, how do we do that? Do we need a loop? Is it necessary?
Yes.
Yeah. You're going to go over all the points, all the entries, and see which one has a matching key, and then return the associated value, right? Why don't we have a look? And then I have a question for you. Let's go back to the slides over here. Okay, let's say we still got our attributes for the array map over here as before. So now let's say, sorry, that's just the as before. So now let's try to do, oh, there's a test case we just have seen. Okay, that one's been done. Get, okay? Look at the header or signature for the get. Given a key of type integer, we want to return the corresponding string value null if the key doesn't exist, okay? So now let's see this. First of all, we should really run a loop to say for integer I, 0 I less than NOE, and now you should know very well why I less than NOE as opposed to I less than entries.length. Okay, good. And then I++, and then I simply say whatever entry I'm currently looking at, I'm simply going to assign that, and then get its key. If its key is the same as the key I'm looking for, that means that's the value I want to return. And then return that particular value. Okay? That's it. Oh, of course, if I can ever reach out of the loop, that means I haven't found anything. I haven't returned just yet. So that means the key doesn't exist, so I can return null. Any question about this implementation over here? I can tell you that this implementation here, even though that's the best we could do, it's very, very terribly inefficient. Why? Let me help you with that. Let's go logically. Let's think about this. I want you to look at the diagram over here, okay? Over here. Okay, is that visible to you? Okay? I want you to look at just according to the current setup over here. If I simply ask you the following, assuming that, okay, sorry, assuming that we got array map, let's say M. Okay, let's say M is already array map, and M is simply pointing to this particular object. If I say M.get 1, how many iterations would it take to return this particular value? If I say M.get 1. Nope, I'm just asking for this particular example. If I say M.get 1, which iteration am I going to return the associated value? First one? Everybody agree? Because you can see that the very first entry over here already has 1 over here. That means we're lucky. Number of iterations you want to think about, okay? Just 1. As soon as we see 1 over here, that means we're going to match this particular condition over here and return right away. Okay? Let's try another one. What about if I say M.get 6? How many iterations would it take? 5, thank you. Very good. Okay? 1, 2, 3, 4, 5. We find it. Okay? Let's say this. According to the current setup, okay, what would be the worst number of times you have to spend for iterations in order to find out the associated value? 7, because I got 7 over there. Okay? Worst case, according to the current setup over there, should be 7. And let's say, to make it even more general, the current array can host up to 100 entries. Let's say the array is completely filled up. What would be the worst case in order to get the get executed? 100, depending on how large the array is, right? You may just have to go all the way until the last one and then realize it's either the last one or you think you haven't found it, right? 100 iterations. Okay? So far so good. And now let me go back to the slides. What you have just finished was these two. These. Let me make it even more general. What if I have an array storing entries for a very big database? I got 1 million entries. What would be the worst case to execute M.get k? Worst case meaning how many iterations at the worst case should I actually execute? 1 million? You simply go from the beginning all the way until the end. but you just haven't found it. Or maybe the one you want to find is simply the last one, right? You usually need a million iterations, okay? What can you see from this pattern over here? Somehow, the number of iterations, the worst case, is somehow related to how large your array is. You agree? Somehow, we said mathematically, it is linear to the size of the array, okay? ON, yeah, so for those of you who have taken 1019, it's called a linear time algorithm, but you don't have to worry, we're going to review that, okay? For now, just remember it's linear to the size of the array, okay? Now, okay, it's simply linear. Now, we want a much faster procedure. And the much faster procedure, we claim that you will need just one iteration to find out anything, just one. That's the idea behind hash table. So rather than running a loop over here, all we're going to do is to have some clever encoding of your key such that every time you want to look up for the value, you don't need to go through a loop. All you're going to go is just go to the position directly. Okay? So now we're going to introduce you the idea for a hash table. Okay? But up to now, any question for me? Up to now, you should just understand that for this particular naive implementation, which is nothing wrong, it's just inefficient. It's correct, but inefficient. It's inefficient because the number of iterations in the worst case is going to be linear to the size of the array. Okay? So now, let's see the idea for a hash table. Okay? And then we'll do some coding for that as well. Okay, let's see for a hash table. So now this is a diagram we're going to use to actually to explain the idea. I'm going to use that in iPad. Okay, let's see what that really means. Let's go back to iPad here. Okay, let's now. Okay, if you can do me a favor, just focus on the diagram over here only. Just that. Let me explain to you conceptually what does it really mean to hash your key. Okay. You already did something called hash code in your lab. So that's exactly what hash code is doing. But now let's explain how to put this hash code into context. Okay? First of all, let's think about the K over here. The K is simply the key you're looking for. Okay, the key can be 1, can be 25, can be 3, 14, anything. Okay? Previously, in the naive implementation, we have to run a loop to check to see which iteration is going to find a matching key with K. But now we don't have to. All we do is we have to somehow define a so-called hash code function. Okay, we'll talk about how to define this in just a moment. But for hash code, it's simply going to take any key and then turn that into an integer. Okay, so now when you see HC of K, HC, which is a hash code, think about mathematically, hash code is like a function. And the function will simply take any key, let's say integer. And then it's going to return an index. Whatever result that's from the hash code function is going to be used as index. Remember we said indexing into an array is very efficient. So once you somehow have converted from K into HCK, you can use HCK as an index. That's the most important step. Assuming that your hash code is well-defined. Okay, we'll talk about what well-defined really means. Okay, let's go a little bit further. So now, once you get this particular expression over here, HCK, it will be used as the index into the underlying array. You can see we no longer notice one thing. Okay, let me just show a comparison to you. Notice that this is very different from if I simply say A and then K, right? It's certainly not the case, right? We're trying to do the hash code first before we apply the indexing operation. Any questions so far? Okay. Apparently there are two steps over here. Step number one, we want to convert the original K into the hash code, and this is going to be index. That's step number one. Number two, we want to use this particular hash code result, use that as the index into the array. And that's also efficient. So converting that into it, usually maybe you just use a modular operation or do some addition. So this is efficient. This is efficient. Altogether, it is efficient. Much more efficient than the naive implementation where it is linear. Okay? Let's do example very quickly. Okay? Let's see this. A very common way to define your hash code function is by saying whatever key value you're given, modulo that with the size of the array. For example, in the previous naive implementation, the size of the array is simply 100. You will say modulo 100. But now in this case, let's assume we have the following array. Let's say this is A. Okay, what's the size? From 0 until 10, we got size 11. So modulo 11, which means any key value you give, doesn't matter how large or how small it is, modulo 11 is going to give you the index value. Okay, let's try to do exercise quickly. Okay, it's a very typical way to do things. To really see more ways to implementing the hash code, you will learn that more in 2011, not this course. We'll just give you an introduction. Okay, so now can you help me out? Let's say if the key is simply 1, what will be the hash code? 1 modulo 11, right? 1. What about 25? 3? Agree? Okay, guys, if you got trouble with 25 modulo 11 is equal to 3, please speak to me after class. I'm more than happy to help. Please, okay? Don't be shy. I'm serious, okay? 3. Okay, what about 3 modulo 11? 3, thank you, very good. Okay, 14 modulo 11? 3. 3, right? Yeah, okay, I know you're teasing me, I know, yeah. Yeah, okay, it's fine. What about 6 modulo 11? 6, thank you. 39 modulo 11. Thank you. 7 modulo 11. 7, thank you so much. Notice one thing. Have you found hash code could be duplicates? For example, you can see we got 3 hash code with value 3. And also we got 2 hash value with value 6. That's normal. It's something called collision. Okay, I'll write it down. It's also on your slides. So this means simply called collision, which means over here you can see 25, 3, and 14. So these are unequal keys. However, for all of them, you got equal hash code. Okay, it's called collision. Okay, so now this is something that's beyond the scope of this course. When you design your hash code, you want to avoid collision as much as possible. But in practice, it's simply unavoidable, especially if the number of entries you want to add in to the array is much larger than its size. Unavoidably, you will get in there. Okay? You will hope that it will be uniformly distributed. That's what you hope. Okay, so now, just very fast point out. Let's say you can see over here, I want you to pay attention to these 3 entries specifically. 25, 3, and 14, right? Also, you got C, F, and Z. Okay, you can see so now question for you first of all these, so these are the 3 entries, so where should they be stored? Where? Which index? Index corresponding to the hash code, right? Because we know that the hash code is simply 3. Okay, index the hash code of the key. Okay, don't forget. So now you can see the hash code is simply 3. That means there's all stored under index 3 over here. And notice that within this particular index, we got more than 1 entries, simply because all those keys map to the same hash code. That's collision. Okay? So this is collision. Simply because the keys over here, so we got 25, 3, and 14. 25, 3, and 14 all have hash code 3. Okay, that is why. So now, there's a catch over here. By the way, let me say one more thing before I tell you the catch. When you got multiple, that's why when you, every element for this particular array is called a bucket. So another way to see the hash table is called bucket array. You can think about every element stored within the array. It's not an individual elements because collision might happen, in which case it's a bucket, just a collection. Okay? So now, here's a catch. If the collision is so severe, you got many entries in a particular bucket. Now, how can you find out a particular key? You still need to have a loop. Unavoidable. Okay? Okay, let me write it down. Okay, and then we can do some example. Okay, let me write this one here. Okay, when a bucket's size is getting too large, it's getting large, it is still expensive to search for the entry. Because the bucket is so large, right? You still want to search for that. So now the hash table, its performance severely depends on how you define the hash code function, right? Okay, but for this course, you can assume almost all the time we'll simply use the modulo operator. Okay? Any question about this? Okay, I hope that's clear. Okay. Okay, after this, let's do a little bit of explain some principle over here. Okay. You know what? I would suggest I go over this principle maybe after we have seen the example. Let me see the example right away. Okay. So let's see until the end of the course, maybe the class, maybe about 10 minutes, less than 10 minutes. Let's do some example, and then we'll go over this principle next time. Okay, it will make much more sense. I want you to have this first example code to consider. Okay, I'll tell you exactly where to look at. Okay. So now let's say we have a class called integer key. Okay, and then we just have a attributes called k, integer. Okay, and then you have constructor here, just initialize the k to be something. And then we have, oh, by the way, the hash code, guess what? Also gets inherited from the object class. Remember we said the object class, they got equals and hash code. Okay, and then for the hash code method, you simply return k modulo 11, assuming that the bucket array size is 11, assuming that, okay? That's a hash code. And then we have our equals method over here, okay? And then we have our cast all the way up to here, and then we say return this.k equals other.k. I can tell you that this is correct, okay? Any question about this over here? Okay, let's go over a test case very quickly, and then I will ask you that question over there at the bottom. Okay, why don't we have a look at some test code very quickly? Okay, so now what I have is the integer key class we just went over is just right here. Okay, all I have is just some JUnit tests over here to strengthen your understanding. Let's try. So now let's try this. Let's say we simply create some variable of type integer key. Let me make it bigger for you. Okay, it's ik1 of type integer key. Okay, and the initial value for the k will just be 1. Okay, so now if I say ik1.hashcode, would you be convinced it should just be 1? Simply because we are going to call the overridden version of the hash code, which is exactly over here, and then it's going to say return the k. In this case, the k is just 1. 1 modulo 11 is 1. Okay, so that's why this should be a pass. Okay, that one's easy. So now, can you just do something for me over here? Let's say I got integer key 31, integer key 31. I want to make them two different objects, so that's why I say 1 and 2. Okay, and then I just say new integer key 39, new integer key 39. I have another object ik6, and then value is simply just 6 over here. Okay, so now having this in mind, can you help me with this? If I say ik39.1, which is this object over here, what's the corresponding key value? 39. If I call hash code, what's that gonna be? 39 modulo 11 should be 6. Thank you. Okay, hash code is like that. Okay, And also, if I try IK39, object 2, which is this object over here, also 39. So that means it's going to give me also hash code 6. And now let's try one more. If I try IK6 over here, and then I say IK6.hash code, it will also be 6. Okay, very good. Now I want you to look at the following over here. I'll write it down over here. If I say the following, IK39 1 dot equals IK6 versus if I say IK39 1, which is this guy here, right? Dot hash code equals IK6 dot hash code. Okay, let's say this is 1, this is 2. 1 and 2. For number 1, do you think it's going to be true or false? False, simply because 39 is not equal to 6, right? Very good. Versus this guy here is going to be 39 modulo 11 versus 6 modulo 11. That will be true. Okay, very good. So what's the conclusion over here? Can you tell me why having two unequal keys will give me the same hash code? What's that word we just said? Not bucket. Bucket is actually the consequence of that. Collision, remember? Yeah, please remember. Okay, I wouldn't blame you. I just said a few minutes ago. Okay, that's exactly collision because you got two keys that are not the same. However, they give you the same hash code. Okay, all right. Okay, any questions? Okay, I would say I will stop over here. I'll give you a little bit time off today. Do you want to hear about the lab test? Yes. Are you sure?